So far, we've been using service decorators quite heavily in this module, but not all the information you need has to come through decorators. One prime example is network requests. We typically want to show the user some sort of animation when there is an outstanding request, because it lets the user know that there is some activity happening. Perhaps we are fetching their data or saving their data. Instead of a decorator for this scenario, the ideal component is an HTTP interceptor. We built some interceptors in the last module, so I won't go into detail about how to build one, but I do want to show you a basic request counter interceptor and how it could work. In this file, I am building a request counter, and just as we saw in the last module, I'm going to register that as an HTTP interceptor by pushing it into the interceptors collection on HTTP provider. And also, as we learned in the last module, an interceptor can have 0 to 4 methods, which are request, response, request error, and response error. We have all of those here, in addition to a function that will return the current number of outstanding requests. So how do we compute the current number of outstanding requests? Well, we simply increment that value whenever the request method on this interceptor is called, and we decrement that value whenever there is an error, a response, or a response error. And we also return the appropriate promise using q.reject when there's an error and q.when for a promise that should resolve successfully. Now, since this interceptor is also registered as a service, because that was a factory method that we were looking at, I can inject this service into other directives and components and controllers, but in this case, I just want to inject it into a directive called workspinner. This workspinner, you can use it as an element or an attribute. And essentially what it's going to do is transclude content and only show that content when there's a true request count, so a request count other than 0. This directive will know that because it's going to set up a watch that keeps monitoring the request count. And since that's a primitive value, an integer, we're going to have to invoke a function to get that. And whenever that request count changes, the second function will be invoked by Angular and it will pass in the new value. We're simply going to say that into our scope. It's an isolated scope in this case. And now how do I use the directive? It's very simple. Somewhere in my notification area, I can just have workspinner. Any markup that I put inside of here will be transcluded into that directive. And this is the content that will show or hide depending on if there is an outstanding request count. Let's try it out real quick. In the error-prone controller, I'm going to inject the HTTP service, and then somewhere down here at the bottom where I typically include initialization logic, I will do a get to /API/slow. That's a special endpoint that I've set up that will take 2 seconds to respond. And now I will make sure I have everything saved. Let's refresh this page. You can see there's our outstanding request. It's going to be around about 2 seconds and then gradually fade away. So HTTP interceptors are another way to collect information, but I do want to examine a very specific scenario here. What happens if there's an error that comes back from the web server? So in this case, I'm going to call an API endpoint that doesn't exist, and the web server should return a 404 error to me. Now, typically, when you are making an HTTP request, you're going to have a .then on the promise returned by an HTTP operation. And it's in here where you can process a successful response. And then you can pass another function, which is your error handler. Now, the one problem I've had with this approach is that when you're working on a team and building an Angular application, if everyone is writing their own local error handler, then the error handlers tend to become inconsistent. One person will write an error handler in a controller that when there's an error, it will add something to the alerting service. Another person might forget to do that. And then yet another person might actually have an error in the success handler, which isn't caught by this error handler, because the promise is either going to invoke the success handler or the error handler. If there's an error inside the code here, that doesn't go into the error handler. So what I'd like to show you in the next clip is how to set up a consistent error handler whenever you're dealing with promises.